Hi students, this is Chapter 9, Lesson 6, the last lesson of the chapter. The topic today is area of composite figures. Composite figures are figures that are made up of two or more polygons. They're also, sometimes you're taking away a polygon's area from another polygon's area. So let's just get started right away. I know that you did do some work with composite figures in the lab, but let's write down our first vocabulary word, composite figure. Okay, a composite figure is a figure made of two or more figures. Okay, composite figure is a figure made of two or more figures, and here are a couple of examples. There's a composite figure. Here is another one. And here is another composite figure. So, composite figures, you have to look at them and figure out what are the shapes that make up the composite figure. And sometimes you have to draw or add a line. So, this figure right here, it's kind of like an L shape. It can be divided into two rectangles. And I could draw a line up and have this rectangle along with this rectangle. I could also draw a line right here and make a rectangle, a longer, skinnier rectangle on top, and then a rectangle right here on the bottom. So sometimes there's different ways to divide up the composite figure. Okay, but this, I'm going to make my I'm going to divide this composite figure into two rectangles like that. So it's two rectangles. This composite figure is a rectangle right there, and of course, actually this, I'm going to get a different color, it looks a little better, and a triangle. So you'd have to find the area of two rectangles to find the area of that. This composite figure, you'd have to find a rectangle and a triangle. And then this composite figure, hopefully you recognize that shape as a trapezoid. These two sides are parallel. And, of course, this is a rectangle. So for today's lesson, you're going to have to go back and use your notes for all kinds of different areas for the shapes that you know. Rectangle, triangle, parallelogram, and trapezoid. Okay, let's look at a rectangle, triangle, composite figure example. So a rectangle, triangle, composite figure, CF. And I'm going to make a rectangle that's 3 units across the top, 1 unit on the end, 3 units this way. And then I'm going to draw 1 line up, 1 line down, 1 over, and then I'm going to connect with using a ruler, that. So that actually looks like a tomahawk. And this is a rectangle, and then we have a triangle. So I'm going to make the triangle, let's see, here's the rectangle, So we've got a rectangle, triangle composite figure. Here is the triangle. And we're going to find the area of that composite figure. So now I'm going to give you some dimensions. I'm going to tell you that this is a 3. This line right here is a 9. This line right here is a 3. This is a 3. And this is a 3, this line. So there are the dimensions for that figure. Always, the big idea with composite figures is to break up the composite into the shapes that you know the area of and start with the formula. So, rectangle and a triangle. Always, always write down the formula. Area of a rectangle is area equals base times height. The area of a triangle is area equals base times height divided by 2. Let's work on the rectangle first. So this is a 9, which makes this a 9, and this is the height, which is 3. So the area of that rectangle, base times height, this is going to be 9 times 3. So the area of the rectangle is 27. We'll say that these are all in feet. So the area of the rectangle would be 27 feet squared. So now let's focus in on the triangle. Remember, triangle is base times height divided by 2. This could be the base. If a bird landed right here, this line all the way down would be the poop line. So bird lands here, this is 3, this is 3, and this is also 3. So that is 9. So let's plug in our numbers. The base of that triangle is 3. The height is 9, and we're dividing that by 2. 3 times 9 is 27. Divide that by 2, and you are going to get 13.5 feet squared. So now we know the area of the rectangle, 27 feet squared. We also know the area of the triangle, 13.5 feet squared. So the very last thing we have to do is put them together. It's one total figure. We're combining the rectangle area with the triangle. So that would be 27 feet squared plus 13.5 equals 40.5 feet squared. That's the total area of that composite figure. Rectangle plus triangle. Okay, next example. Find the area of this composite figure. Okay, and this rectangle, triangle, we were also finding area, so we can put that up here for area. Okay, I'm going to give directions on how to make the next figure. So make, let's see, 4 lines across. Okay, 1, 2, 3, 4. 1, 2, 3, 4. 5 lines down. 1, 2, 3, 4, 5. And this is also 4 across the bottom. 1, 2, 3, 4. And make a line that comes down 1 from the top, 1 from the bottom, so it looks like that. And then we're going to skip a line and skip a line right here in the middle, so it looks like that. And then we're going to connect. So that is the area. We're trying to find the area of that figure right there. So again, you've got to look at it close, and this one is this entire shape, if I were to connect this line right here and just trace this, look how my fingers are tracing, that is a rectangle. So to find the area of this shape, we're not going to be combining two shapes. We are going to find the area of this rectangle, and then this piece, it's kind of like a bite or a chunk out of it. We are going to find the area of this, and that shape is a trapezoid. So we're going to find the area of a rectangle, we're going to find the area of the trapezoid, and we're going to subtract the trapezoid area from the rectangle. So I'm going to trace the rectangle. Here is the rectangle right here in pink. And here is the trapezoid. Actually, I'm going to pick a different color. Those don't show much of a difference. I'll use blue. Here's the trapezoid. And now let's put some numbers to that. We're going to say that this down along the bottom is 20, which makes this 20. That's the same line. We're going to say that this side is 25. And we are going to say that this from here to here is 5. We are going to say from here to here is 15. And we're also going to say that this distance right here is also 5. So I know that there's a lot going on right here, but let's break it down. The rectangle, so we're going to find the area of the rectangle and the pink, and then we are going to subtract the area of the trapezoid. That's the piece, this chunk here, the blue chunk we're taking out. So again, start with, always start with formulas, very important. Area of a rectangle, base times height. Area of a trapezoid is, look back through your notes, it's base 1 plus base 2 times height divided by 2. Base 1 plus base 2 times the height divided by 2. So the area of the rectangle in pink, here's the base, here's the height. So the numbers that we would use would be 20 times 25. Calculator that, and you're going to get 500. We'll also say that this area is in feet, just to give it a unit. 500 feet squared, that's the area of the pink. Okay, but we want the area of this shape, so we want to remove this blue from the pink. So now this trapezoid, you're going to have to imagine that we rotate it. Here are the bases right here. Here's a base, and here's a base. Base 1, base 2. Base 1 is 15, base 2 is 5. So base 1, 15 plus 5. Now my height would be, I would be turning it this way. The bird lands here, and that would be the height. If my trapezoid, actually I'm going to draw it right here. What I'm talking about is if we turned this sideways, here is the trapezoid. It looks like that. I just took this piece out and I turned it this way. So base 1 plus base 2, and then this is the height, this line, and then divided by 2. So that gives us, oh, I also forgot, base 1 plus base 2 times the height. So plugging in our numbers for the trapezoid, parentheses we would do first. So we would get 20 times 5, which is 100. Divide 100 by 2, and we would get 50 feet squared. That's the area of the trapezoid. So now what we have to do is we're taking the rectangle take away the trapezoid. So 500 feet minus 50, taking out that piece, gives us an area of 450 feet squared. All right, the last example. The hidden treasure for this lesson is graphing an ordered pair. You need to be able to explain, if your name gets picked, how would you graph the ordered pair -4, 2? So you'll have to sketch a quick coordinate plane and show here's where the coordinates, the ordered pair -4, 2, where those would go when you graph that. Okay, last one. Overlapping figures. So again, we're going to find the area. And overlapping figures. It's another kind of composite area. So make a rectangle that's 3 units across. Actually, this one will be a square. It's 3 by 3. Still a rectangle, but it actually is a square as well. And then right here, 1 box over and 1 up, draw a line that's 4 across. So 1, 2, 3, 4. And then 2 down. No, I'm sorry. 3 down. So 3 on this side. So I want you to draw that. And we want the area of this shape. What's the area of this shape? Well, there are 2 rectangles, this rectangle, but if we find the area of this rectangle, that means we've already counted this part right here, and if we find the area of this rectangle, we've also found the area of that. So we have to find the area of rectangle. Let's number these. Rectangle number 1, rectangle number 2, and then we have to subtract the area of rectangle 3 because we don't want to double count it. We're already counting the area of 3 when we find the area of 1, and when we find the area of 2, we are also finding the area of 3. So we have to find the area of 1, the area of 2, and then subtract the area of 3. So now let's give some numbers to this. I'm going to tell you that this side is 21. This is 24. So even though this looks like a square, now that remember we go by the numbers, not by what it looks like. So now I know this is actually not a square because it's 21 by 24. Can't go by looks. That's something that we've talked about before. You use the numbers. This is a 28, and this is 21. So now let's label the area of rectangle 1, the area of rectangle 2, and the area of rectangle 3. The formula is the same for all of them. Base times height, and base times height. So rectangle number 1 is this. That is a 24. The height is a 21. So I would say that this is 24 times 21. So I'd get the area. And when I multiply that, I would get 504 units squared. Rectangle 2. Base is 28. Height is 21. So 28 times 21. Multiply that out, and you get 588 units squared. So now the tricky one, rectangle 3. We've got to figure out what this is and what this is. Oh, I forgot. Darn it, I forgot to give you some numbers. This side right here, this is a 14. And this side right here is a 13. So now we got to look at rectangle 3. How do we find the area of this? And this can be tricky. I'm going to get my highlighter out and just show you. Using this number and this number, we can figure out this side of rectangle 3. So when I highlight this, you can see that that's a 21. Well, if I take this same line and I slide it over here, I know that this orange line is also a 21. That means this missing amount right here, it has to be a 7. 21, this is 14, and I have to have, it has to add up to 21, so this right here has to be a 7. This right there. I'm going to use this line to help me figure out this side of triangle, or of rectangle 3. So let me get a different color. I'm going to use green. So I know this line is 28, which means this line is also 28. If this line is 28, this green line is also 28, and I need to do 28 subtract 13 to give me this part of the green line. 28 take away 13 is 15. So now I know the dimensions of rectangle 3. It is 15 by 7. That will give me the area of rectangle 3. Base is 15, the height is 7. So this is pretty complicated. A lot of 6th graders struggle with an area like this. Please ask for help if you can't, when you have a shape like this that you can't figure out. I'll help you. We'll get out the highlighters and we'll draw lines, and I'll help you figure out the missing dimensions that you need. 15 times 7 on your calculator gives you 105 units squared. So now, area of triangle, I keep calling this area of rectangle 1 plus the area of rectangle 2, subtract the area of rectangle 3. That's the last step. So 504 plus 588, subtract 105. If you enter that into your calculator, your final area is 987 units squared. And now I'm going to show what that is in a different color. So what we just found was this. 987 units squared is the area of this whole figure. That shape is 987 units squared. Rectangle 1 plus rectangle 2, subtract rectangle 3, because we do not want to double count rectangle 3. Okay, that was a big one. I know this lesson, a lot going on. Really, the focus is dividing the composite figure into the shapes that you know and starting with the formulas. And ask. If you can't tell a dimension of one of the shapes that you're trying to find, these can be tricky for a lot of kids. So please ask. Okay, start reviewing lessons 1 through 5, as well as lesson 6 for chapter 9. Your test will be coming up soon for chapter 9. Talk to you soon.